Hello everyone, welcome to another video of mine, and in this video I will be solving question number 5 for May-June 2013, and the paper code is 32. So this question is related to the topic of differentiation, and in particular we are going to be using the technique of implicit differentiation. So we use implicit differentiation when we can't make y the subject of the equation. So that is when we use implicit differentiation. So that is what is going to be used in this question over here. So like now let's go to the question and read it what it's saying. This is the curve of the equation. The diagram shows the curve with equation. This is the equation of the curve where a is a positive constant, so we know that a is greater than 0. If we the reason why we know it's greater than 0 because it is written positive constant over here. Otherwise it would have, if it was equal to 0, then it would have been written a is a non-negative integer or is a non-negative constant, but it is not written over here, so that is the reason why we know a is greater than 0. The maximum point on the curve is m. Find the x coordinate of m in terms of a. So this is the maximum point, and we already know at maximum point dy over dx is equal to 0, and this is at m, this is going to be the y coordinate, and this is going to be the x coordinate, and we have to find the x coordinate in terms of a. So let's get started. So we are just simply going to differentiate it at first. So we know that x cube's differentiation is 3x square, first derivative. Then we can see xy square, product rule is going to be used over here. So we know that in product rule, if we have uv d uv, so we know that we write u as it is, first derivative of v, plus v, first derivative of u. So that's going to be used over here. So we're going to write x as it is, and then we're going to differentiate y square. So the differentiation of y square will be 2y, and dy over dx, we write dy over dx when we're going to differentiate y square with respect to x. So that is the reason. So this is implicit differentiation. We're getting dy over dx when we're going to differentiate y square. So you should be knowing this is really important. Plus, so I'm going to write y square as it is, and the first derivative of x is going to be 1. So the product rule is done. Now we have plus ay square, so plus 2ay, and again we're going to write dy over dx, minus 3a square 6ax is equal to 0. That is going to be the derivative of that is equal to 0. Now what we're going to do, we're going to try to make, we are going to take dy over dx common over here, but let me write it in a much simplified way where where they're much closer together. Dy over dx plus 2ay dy over dx plus 3x square plus y square minus 6ax is equal to 0. So we're going to be taking dy over dx common over here. I won't be taking 2y or 2y common also, as I won't be taking 2y common over here, and you're going to realize it why I'm doing this step. And then we have, and then I'm going to take these terms to the right hand side over here. So moving forward, dy over dx is going to become common over here, dy dx, and I'm going to have 2xy plus 2ay over here, plus 2ay is equal to minus 3x square minus y square plus 6ax over here. So I'm going to multiply both sides by 2xy plus 2ay. So we're going to get to dy over dx is equal to minus 3x square minus y square plus 6ax over 2xy plus 6ay. So now we are done till here, but we already know from the question that this m is a maximum point, and at maximum point dy over dx is equal to 0. So we're going to simply we are going to write dy, we are going to write 0 over here instead of dy over dx, because m is a maximum point. At maximum point dy over dx is equal to 0 at maximum point. dy over dx is equal to 0. So it's going to become 3x square minus y square plus 6x over 2xy plus 6ay is equal to 0. So we are just going to multiply it over here, multiply 2xy plus 6ay on the both sides is going to get cancelled, and we're going to be left with only minus 3x square minus y square plus 6ax is equal to 0. So now we're going to make y the subject over here, so I'm going to take y onto the right hand side. So this can be written as then y square is equal to minus 3x square plus 6xy. I have added y square on the both sides, so over here it's going to get cancelled, plus y square cancel, and plus y square, so we're going to get that over here. So now if I go again to the equation, we can see that over here it's y square, over here it's y square, and I can simply substitute the value of y square in the equation to find the value of x in terms of a. So that's what I'm going to be using, substituting the value of y square in equation of curve, substituting the value of y square in equation. So what is the equation? Equation is x cube plus xy square plus ay square minus 3ax square is equal to 0. And what is y square? Y square is y square minus 3x square plus 6ax, sorry, my bad. So now simply x cube as it is plus x. Now this is simply algebra right now, so I'm going to request you to stop the video and try to do it on your own. It ain't that difficult. Minus, try to simplify it, and obviously for the next step you can again resume the video and see. Minus 3ax square is equal to 0. X cube plus, sorry, this is what I don't know why I'm minus 3x square plus 6ax square minus 3ax square plus 6a square x minus 3ax square is equal to 0. So this is going to become minus 2x cube. This and this is going to give us plus 3a x square, and just let me write it over here, minus 3x square plus 6a square x is equal to 0. You can see this and this is going to get cancelled, and minus 2x cube plus 6a square x is equal to 0. So I'm going to be taking minus 2 common over here, so we're going to be left with minus 2, sorry, minus 2x is going to be common over here, my bad, minus 2x x square plus 6a square, oh my bad, oh god, sorry, let me use an eraser over here, sorry, that's going to, but the work should be neat and clean as well. Okay, then I'm going to be taking minus 2 common over here, then we have minus 2x is going to be common over here. Again I made that mistake, I'm really sorry. X square and plus 3, sorry, minus 3a square is going to be a common over here is equal to 0. So moving on to the next slide. So what do we have? We have minus 2x x square minus 3a square is equal to 0. So what do we know? That minus 2x is equal to 0 can be equal to 0, or x square minus 3a square can be equal to 0, right? So x is equal to 0. So this can't be an answer because x isn't in terms of a, and you can also see it from the graph where the m coordinate is, the x coordinate isn't 0. So this is rejected, reject. And then we have x square is equal to 3a square. So taking square root on both sides, what we are going to get, x is equal to 3a square. So we can, so this is going to be written as x is equal to plus or minus 3 into a square. So this square root and this square root is going to get cancelled, and we're going to be left with x is equal to plus or minus under root 3a. But the minus is going to get cancelled out because we already know that from the graph it can't be that. So x is equal to positive 3a. This is our answer, and negative 3a under root 3a is rejected. So this is your answer. I hope so you understood it and you were able to know what was going to happen over here. So at the end, I'm also going to want to add one more thing. So give me a moment, and I'm going to see. Well, I want to tell you something related to the different implicit differentiation, and this is our answer. So give me a moment, and I'm going to tell you what. So the thing that I want to explain to you is that, for example, when I am differentiating y square, then y I'm writing 2y dy over dx. And for example, when I'm differentiating just x square, I don't write it as 2x dx over dy, or I don't write it as 2x dx over dx. So here's the main thing. So when we differentiate x square, so this is usually 2x dx over dx. But we don't write it because this dx and this dx, you just don't need to write it because it's going to cancel out and it's going to give 1. So I'm just giving you an intuition that why are we using 2y dy over dx. See, this is a 2y. We differentiated y dy with respect to x dx. So that is the reason why we have dy over dx over here. And when we are going to differentiate x square, we don't, because these and t, because this and this is going to cancel out. Please remember that this is just an intuition that I'm trying to give you, that I'm trying to make you understand what is happening. Maybe the logical reasoning is something else, but for A level standard, this is the thing you should need to have in your mind. So yes, that's it. So please do like, share, and subscribe to my channel. Comment your thoughts if there's something I'm missing or I can improve myself. So please do that. And yes, that's it for the day. Thank you so much.